Hi guys, welcome back to my channel. Hope you are doing well. Today I'm going to teach you electrolysis of ionic compound. All the ionic compounds, whether they are in the molten condition or the aqueous solution, can conduct electricity. And why I have chosen this topic, uh, when you check my last video, I've already started redox reaction. So this type of electrolysis is a kind of a redox reaction. Reduction and oxidation take place at respective electrodes. We will see how the electrolysis of NaCl take place, and I want to show you a small practical of electrolysis of aqueous NaCl. Now look at that. Electrochemistry is a branch of the chemistry mainly that deals with electricity. When you pass electricity through the solution, mostly ionic compound, we know ionic compound conduct electricity. It it breaks the ionic compound into its ions, and the ions move to the respective electrodes. The electrode which is connected to the negative terminal of the battery is called cathode, and the electrode which is connected to the positive terminal of the battery is called anode. Okay, and we know that why the ionic compounds conduct electricity. Any guesses? Because they have free ions. Only they can conduct electricity in the molten condition or in the aqueous solution, not in the solid state. For solid ionic compound, they have no movement of ions. That's why they can't conduct electricity. Yeah, look at that. So when you pass electricity through molten NaCl, molten NaCl is easy. So that electricity break the NaCl into Na plus and Cl minus. So Na plus split into ions like Na plus, take one electron from the negative terminal which is cathode and get deposited as Na solid. Gain of electron. Gain of electron is called reduction. Reduction. Now, chlorine, mostly the non-metal, discharge in the form of gas, and the metals get deposited. Look at the chlorine. Chlorine lost electron, Cl minus, and become chlorine gas. Have Cl2, take 2Cl. Sorry, take 2Cl. We don't have just one chlorine molecule or one NaCl. We have a lot of NaCl. It's a salt, so we have so many NaCls. So look at that. Take two chlorine, you're getting Cl2 gas plus 2 electron. Chlorine lose electron and sodium gain electron. So loss of electron is oxidation. Oil rig. I have already explained oil rig. Reduction is the gain of electron, oxidation is the loss of electron. So chlorine get oxidized at anode. So chlorine give away the electron to anode and discharge as chlorine gas. So chlorine gives away the electron and comes out as chlorine gas, Cl2. And sodium get deposited at the cathode. We will do the same experiment here. I will show you how it works. Now look at that. Look at this is the electrolysis of aqueous NaCl. This setup is called Nansen cell. We will get three valuable products at the end of the electrolysis. So here a bit tricky. We have H2O. Aqueous means water molecule, guys, and we have NaCl. Look at that. This is molten. Simply, molten means Na split as Na plus and chlorine as Cl minus. But here we have two positive ions, H plus ion and Na plus ion. and two negative ions, Cl minus ion and OH minus ion. Look at that. Now we have to decide which one goes to cathode. We know that positive ion discharge or deposited at cathode. That's why positive ions or ion is named as cation, because it is discharging or depositing at cathode. And a negative ion, look at the negative ion, chloride ion, discharge or comes out as chlorine gas at anode. That's why it's called anion. So negative ion is called anion and positive ion is called cation, because they are discharging at respective electrodes. Look at that, guys. Can you let me know which one goes to cathode? Is the H plus or Na plus? To figure out that one, we have to we have to look at the reactivity series. When you look at the reactivity series, hydrogen is below the sodium in the reactivity series. It means that hydrogen is less reactive than the sodium. So sodium displaces hydrogen. So hydrogen moves at cathode. Hydrogen ion comes out as hydrogen gas at cathode. So we have here H plus as H2 gas, and there is a competition between two negative ions, two anions, and we have two cations, but I have just now explained you which one is more reactive will be settled down in the solution and a less reactive will be discharged. Now look at the two negative ions. When we have a two negative ions, which one will discharge? Either the Cl minus chloride ion or hydroxide ion. So look at that. Remember that whenever we have non-metal or any non-metal with a negative charge in comparison with hydroxide ion, the non-metal, the negative ion will be discharged as any gas, like chloride will be discharged as chloride gas, like bromide will be discharged as bromide gas rather than oxygen, because this is lighter and this is heavier ion. So whenever we have any two non-metals or any two negative ions in competition, so the one which has no oxygen will be discharged in place of the ion which has oxygen. So who will be discharged at anode? Chloride will be discharged. Chloride will be discharged as a chlorine gas at anode. Cl2 plus 2 electron. Same thing, loss of electron, loss of electron. So oxidation take place at anode, oxidation take place at anode, and reduction take place at cathode. Cathode reduction, anode oxidation. I've seen many past paper questions. What will be the end product when we electrolyze aqueous NaCl? Let's see. So hydrogen comes out as H2 gas, chlorine comes out as Cl2 gas. So at anode, so I'm writing here, at anode chlorine gas discharge, at cathode hydrogen gas will be discharged. And what will be left out in the solution or in the beaker? Any guesses? Look at that. Sodium and OH minus, which is nothing but sodium hydroxide. So the cell is left out. This is called cell or a beaker. Yeah. So the cell is left out with NaOH solution. So at the end of these practical or this electrolysis, we will get a three valuable product, a pure product, hydrogen gas. You can collect the hydrogen gas. It will not mix with chlorine gas separated out. So hydrogen at cathode, chlorine at anode, and the cell is left out with sodium chloride. Sorry, the cell is left out with sodium hydroxide. Let's see, guys. I will do this experiment in front of you. I have a small setup to do this experiment, and this experiment, whatever I'm doing here now, is not involve any risk or neither associated with hazards, guys. You can do this experiment at home, but make sure you have to take a little precaution. Always wear gloves or wear your goggles. Yeah. Now look at that. I'm using this sodium chloride salt as a pure sodium chloride salt. I have added 5 gram of sodium chloride salt in 150 ml of water. I completely stir that one so that no bits left out. Now look at this setup. I have, this is called graphite electrode. I have 2 graphite electrode. One I connected to the positive end of the battery. So that positive end of the battery, when you connect the electrode to the positive end of the battery, this become cathode, anode. To demonstrate this experiment, I have a small setup. Look at that. I'm using beaker like for my cell, and I'm using 150 ml of water and add a salt. I'm using sodium chloride, a common salt, which you can get easily. You can get from Amazon or any store. So I'm adding a little amount of salt. Then you have to stir it. Add a salt, and you have to stir it completely. You can add some 5 gram or 10 gram. So 5 to 10 gram. Yeah. Okay. Now I want to show, and make sure that no bits left out when you stir it. Completely stir the salt. Make aqueous NaCl solution. That's my aqueous NaCl solution. Look at that. So I think I have dissolved all the salt. Yeah. Look at that. Okay. Now I have constructed Nelson cell. You can also do at home. So this is my Nelson cell. Now I have a setup. Look at that one. That's the battery. I'm using 9-volt battery. You can use the 12-volt batteries, or we have a power pack. In the colleges, we have a power pack so that we can control the voltage, guys. We need, for this experiment, we need 2 leads. These are called the leads. These are called leads, like that. You can easily get the leads. Look at that. And these are called crock clips. So we need 2 crock clips. Look at that one. That's the graphite electrode, and one more crock clip that goes here. And when you connect this crock clip to the negative end, look at the negative end, to the negative terminal of the battery, that electrode become, any guesses? Cathode. Negative end, cathode. Look at that. Negative end of the battery, that's the cathode. And one more, which is connected to the positive end of the battery, that become anode. Look at that. This is one more electrode, and I'm going to connect that to the positive terminal of the battery. That's the positive terminal of the battery. Now look at that. That's my setup. My setup is ready. Now we can do the experiment. Yeah. I just want to change that one. This to that one. Okay. No. Okay. And to the that one, we have electrodes, one electrode here and the one electrode here, and another electrode to this end. That hopefully, okay, let's see the discharge of gases at the respective electrodes. Yeah, look at that, guys. Just a moment, I want to connect properly. I didn't connect it properly. Yeah, okay, look at that. Look at that. Can you see the discharge of gases, guys? And you can feel the chlorine smell. Look, it's like a kind of swimming pool water. Swimming pool water is a bleach, so we are generating bleach. Even I can smell it. Can you see that? Look at that. One more time. So at cathode, hydrogen gas is liberated. At anode, chlorine gas is liberated. So at cathode, reduction take place. At anode, oxidation take place. So this is a kind of redox electrolysis. Look at that. Can you see that one? Yeah. And let's see. I told you at the end of the electrolysis, we end up with sodium hydroxide. I will check that sodium hydroxide with the pH paper. Let's see. I want to check with the pH paper. I have, see, at the end of the electrolysis, we're left with the sodium hydroxide solution. How can we check the formation of the sodium hydroxide? We have pH paper, which is a good indicator. Normally, we have two different types of pH paper. One is blue in color, and one is like kind of orangish. So when you dip this orange pH paper into the alkaline solution, it turns to blue color or purple color. Let's see the formation of sodium hydroxide take place or not. Let's see. Look at the color. It's this color, and you can see the colors, guys. Look, you can see the colors and the pH values. So if the pH value is less, it means solution is acidic. If the pH value is more than 7, the solution is alkaline solution or basic solution. Look at that. So look, I want to dip that one, this pH paper, and let's see whether it turns to blue or purple. Let's see. One more time, I want to do this experiment. Look at that. Again, look at that. Discharge of gases at the respective electrode. Look at that, guys. I think you can see clearly discharge of gases. Even you can smell the chlorine gas, like a bleach type of smell. Look at that. I want to check the formation of sodium hydroxide by using the red litmus paper. So red litmus paper turns to blue if the solution is alkaline. Look at that. See that? It's turning green, then slowly it turns to blue, and this clearly indicates the formation of sodium hydroxide in the solution. Like I want to do last time, I want to show you one more time. Look at that. Yeah, the reaction is vigorous, guys, very vigorous. Once you dip your electrode in the solution, discharge of hydrogen and discharge of chlorine gas take place. Yeah, even I can smell chlorine gas, guys. Look at, and look that. Yeah, see the reaction. So it clearly shows me the formation of sodium hydroxide. Did you enjoy this experiment, guys? So hope in the future I will get this type of experiment, and I will to make the videos on this type of experiment, like the formation of sulfuric acid by the electrolysis of copper sulfate. And look at that one more time. So when we do the electrolysis of aqueous NaCl, we will get hydrogen gas, which is discharged at cathode, and chlorine gas, which is discharged at anode, and the cell is left with sodium hydroxide. We have seen this experiment, and I want to stop here. I will come back with a new video. Please write any question if you have in my comment box. Thanks for watching.